Welcome back to Logarithmic Expressions and Equations. In this first video in this series, we're going to review some of the log laws and use the log laws to both simplify expressions that have logarithms and also solve equations that include a logarithm as well. The first thing I want to point out in this video is the log laws. Now, technically, the log laws only refer to these three statements here. If you've got the log or ln of the product of two things, you can split that up into ln A plus ln B. You can also go vice versa. So if you're trying to write a couple of things as a single logarithm, then we're using that rule. The second rule is very similar. Ln of A divided by B is equal to ln of A minus the ln of B. Notice how we do have multiple lns here and a single ln on this side of the equation. So you can use these two rules to turn an expression where there are multiple lns separated by pluses or minuses into a single logarithmic expression. That's really useful when it comes to solving logarithmic equations. The third law is our power law for logarithms. If you've got ln of something to a power, you can bring that power out the front. Please keep in mind this is distinct from the calculus power rule. We're not changing that power at all. We're literally just bringing it out the front. Notice also that this is not equal to the ln of A all to the power of n. That power of n here is just applying to that A, not to taking the logarithm of it. Right? So we're taking the logarithm of A to the power of n. It's not the logarithm of A all to the power of n. The second two laws that we have here are really about how e and ln cancel each other out. The logarithm of e to a power, we just write that as whatever that power is. So taking the log of e to something cancels out the e. If we've got ln of something and we want to get rid of that ln, we raise it as a power of e. So e to the power of ln a, the e and ln cancel out, leaving us just with the a. And finally, a couple of special rules that are worth being well aware of. If you've got ln of 1, that's always going to be equal to 0. It relates back to this rule here. Ln of e to the power of 0, bring that 0 out the front. That's 0 times ln 1. That's always going to be 0. Ln of 1 over a number as well, often we simplify that as being negative ln a. The reason being this is a to the power of negative 1. Let's get into some examples and you'll see how this is working very, very quickly. So we're going to first of all write ln 4 plus ln 45 minus ln 10 as a single logarithm. The trick to doing this is to basically go anything that we're adding together, right? Any logs we're adding together, we're going to multiply those. Any logs that we're subtracting, we're going to do a division. Okay, so what this means is ln 4 plus ln 45 minus ln 10 as a single logarithm. Any of those logs that we're adding together, we're going to write on the top line. And the log, in this case, that we are subtracting is going to go into the denominator. Now, just a quick point, we are going to change this very, very slightly. What if this 45 was in fact, if ln 45 was in fact minus ln 45? Then we would want to have 45 in the denominator as well. We're going to be multiplying the 10 and the 45. Okay, that's going to give us, I guess, our proper answer there. Let's just undo that. We'll get back to the original question. So that's ln of 4 times 45 divided by 10. We can simplify that down a little bit, and that becomes, in fact, ln of 18. Just using our calculator for this part because we can. Example 2.1b, we've got a couple of logs. We want to write this as a rational number. That means we want to write it as a fraction without any logarithms. Now here we can see we've got logs in the numerator and denominator. What we need to do in these situations is recognize that both of these logs, or both of these numbers, can be written as a power of 5. That then means that we can bring that power out the front and then cancel out the logs, leaving us with 2 on 3. In example 2.1c, we've got another logarithmic expression, and we want to write this as a single logarithm. Now, this is a little bit different to the first example that we did because we've got some x's in here, but the process is going to be the same. We want to try and write this as a single logarithm, so we basically really want to be using the second log law because you've got a log take a log. But I'm just noticing, we've got a couple of things in here. Let's try and make this a little bit friendlier before we get too far. This here is equal to the negative of x squared minus 2x plus 1. I'm doing this because I'm recognizing this is a quadratic, but I really don't like trying to work with quadratics when the coefficient of x squared is -1. So I've just taken -1 out as a factor. Really, I've just changed the sign of each of these and then put a negative out the front. Now this looks a little bit friendlier and a little bit more familiar. In fact, if we think about our quadratic rules, this is a perfect squares quadratic, so we can write this as x minus 1 all squared. And now what I'm noticing is we've got ln of x minus 1 minus ln of negative x minus 1 all squared. We're seeing something that is going to cancel out in a moment. So let's write this as a single logarithm. It's ln of x minus 1 over negative x minus 1 all squared. X minus 1 is a common factor. Let's get rid of those, leaving us with 1 on negative x minus 1. We can do a little bit of tidying there. That's the same as 1 on 1 minus x. And in fact, negative ln 1 minus x is the nicest version of that particular answer that we can give. Example 2.1d. Here we've got a logarithmic equation. The key thing that we want to try and do to solve a logarithmic equation is we want ln of the left-hand side is equal to ln of the right-hand side, meaning that we can then write that the left-hand side is equal to the right-hand side without the logarithm part. Really what we're doing there is we're raising both sides as a power of e. Now looking at this, we can see that we've got the sum of two logarithms here. So let's write this as a single logarithm. Ln of 4 take 3x times 1 plus x. That's equal to log 4. Now that we've got log of the left-hand side equals log of the right-hand side, we can just write this as 4 take 3x times 1 plus x is equal to 4. Now we do want to try and solve this, so we're going to need to do an expansion followed by a solving. So expanding this out, we get 4. 4x minus 3x is equal to 1x minus 3x squared is equal to 4. Those two 4's, they cancel each other out quite nicely, and we have a common factor of x, so we get x minus let's do that right. X bracket 1 minus 3x is equal to 0. So x is equal to 0 or 1/3. It's always worth double checking your initial conditions, because we need to make sure that whatever is inside of those brackets is still positive. Okay, and that's going to work in this case. Ln of 4 take 3 times 0 is equal to ln 4, plus ln 1, which is equal to 0. That's equal to ln 4. That works. 1/3. Ln of 4 take 3 times 1/3. That's equal to ln of 1. No, sorry, ln of 3, I reckon, all up. 3 is a positive number. 1 plus 1/3 is also a positive number. So we're all good. We would maybe have some problems if this was a larger positive number. Finally, we've got example 2.1e. This one looks a little bit different. What we need to do is basically play my favorite game, which is spot the quadratic. Spotting the quadratic here means recognizing that we've got something squared, we've got a multiple of the same thing, and maybe a constant. Let's do some rearranging of this equation and see what we get. So ln of x all squared minus ln of x to the power of 5 minus 14 is equal to 0. Everything's on the same side. Ln of x all squared minus 5 ln x minus 14 is equal to 0. Now this looks like a quadratic. We could very easily just write this as, instead of having ln x, like a capital X. Okay, that's really emphasizing the quadraticness here. We're going to leave it as ln of x because we can. Using the sum and product method here, we're looking for two numbers that multiply to give us negative 14 that add up to negative 5. Those two numbers are negative 7 and positive 2. And instead of x, we've got ln x. So this means ln x is equal to 7 or negative 2. E to the power of both sides means we get x is equal to e to the power of 7 or e to the negative 2.